And welcome to the React Show. We got a really fun show for you guys today. We're going to talk about a performance bottleneck I recently ran into with React and how I solved it. Yeah, it's going to be great. I'm Thomas. This is my host, Austin. We're with Owl Creek, a high performance React consultancy. And so, yeah, it'll be fun to actually talk about performance. I think it'll be our first episode on that, and I'm sure we'll have more to come. But yeah, we can get started. So first, I'll talk about like real quick the steps that I use to solve bottlenecks. And this actually comes from a book I'm working on, which is a continuation of a book I recently published, Foundations of High Performance React. So I'll just run through that real quick, and then we'll actually like talk about it with a real world example. So the first thing is describing the bottleneck. Next, we measure it. Then we identify the source of the bottleneck, diagnose what's causing the bottleneck, look at possible solutions, and then the last step is actually selecting the right solution and implementing it. Yeah, so welcome to the show, Austin. It's great to have you once again. And yeah, I look forward to talking about this with you.
Thanks for having me here. Yeah, before we get too far into it, you mentioned your book. On the website at owlcreek.studio, don't we have a sign up where you can get the first chapter of the book uh, at some sort of at LeanPub, I believe?
Yeah, absolutely. Thanks for reminding me. Yeah, so if you are interested in learning more and especially like digging deep into how to understand how React works and figure out performance issues, you can check out the book at owlcreek.studio and we'll give you some of that for free even. Yeah, so great idea. Great point, Austin.
Yeah, it was
um,
a nice intro. I read through the book a few weeks ago, and it was cool following the code examples step by step, just creating a little, like a miniature working version of React, and just getting an idea of like when you understand those fundamentals at that level, then you kind of like can look at all the bigger problems that you approach with like a new eye. So it's definitely a good read, and I look forward to the whole book when it's done.
oh, thank you. Yeah, I definitely could not have said that better myself. Um, yeah, so all right, let's do it. The I'll start by doing the first step, and I'm also just going to do it because it'll make this more interesting. But yeah, that is describing the performance bottleneck. I'm working with a client, and they have some software that allows you to scan a bunch of items in a warehouse. Well, we kept getting reports that if you have too many items to scan, essentially, it doesn't work. People would say, oh, it just won't load, or the browser crashes, or whatever. And so to me, that's like a pretty strong indication that there's a performance issue. Um, and and so the first thing I did is try to describe in detail what this issue is. Like, under what circumstances does it occur? Are there things that trigger it? Are there things that don't trigger it? Like, does it work in some cases? So I try to like really dig into that as much as I can to at least form like a mental image of what I'm dealing with. I mean, a lot of people will skip this step. I think I've found it to be really useful because I have had assumptions in the past. I'll be like, oh yeah, there's some performance problem. It's probably this. And I'll just like jump right to what I think it is. And I would say like 50% of the time at least, I'm wrong. And maybe I'm just wrong and bad at doing that kind of thing and everybody else is better. But I suspect I'm not alone, and making
I think we
assumptions.
talked about that in the debugging episode last time, is like making sure you really ask enough questions and really take time to figure out where you're approaching the problem from before you waste time on all these unnecessary tangents.
Yeah, that's true. That actually ties in really well. I actually think of performance issues as a sort of like specialized bug, really. So it makes sense that we would use a similar technique. Yeah. it is a bug that we're trying to solve, but we also we can sort of develop the process deeper because it's can often be a more challenging bug, and it's also a recurring thing. So yeah, that's why we have this process. But yeah, great point. Yeah, so that's the sort of high level bug that I was looking at. What do you think I would do next, Austin, if you had to guess after I've described what it is? What comes next? I'm testing your memory here.
Well, whichever one of the cases that seem to be like the most easy to replicate the bug, you'd try to replicate it. I don't know if I remember the steps 100% because I butted in with the ebook plug. Uh, that's all I was thinking about when you were going. I was like, oh, we should mention the ebook. Um, but am I right that you'll want to go for like the most reliable, maybe most often reported case of it not working properly and see just
Yeah.
like try to replicate it?
Yeah, that I didn't have that in here specifically, but I think that is kind of what I mean by the next step, which is measuring the bottleneck. And
Mm,
part of that is figuring out how to accentuate the bottleneck the most I can. So, like in this specific case, I'm like, okay, I'm going to load this up with a ton of items to be scanned because I really want to bog this thing down and get a really good, like, make it really clear where the issue is. And so that's exactly what I did. I tried a few times, just tons of items, and I, I'll talk about how I, narrowed it down next. But like, yeah, figuring out like where to look starts by measuring in some way. And what I've done before, this was actually an easy case, the one I'm talking about now. I've had much more difficult ones. Actually, even before React, I worked on a site that had a performance issue, but I couldn't really get it to happen on desktop devices. And this was before we had like good emulators and stuff. So I would just go through the code and add loops. Um, until I found like the place to put the loop that made it so the bottleneck showed up on my phone more. And I used alerts with like timers to tell me how long things
mm,
took. It was horribly
nice.
cumbersome, but it's all we didn't really have a lot of the tools that we have now, and especially the some that come with React and stuff. But what mattered was like actually measuring it. Like you need to measure it. If you don't measure it, you'll never know if you've solved it. I have worked with so many people now that are like, "Oh, I solved my performance issue." And I'm like, "Oh, really? How'd you solve it?" And they're like, "Oh, I did this." And I'm like, "How do you know that was the problem?" "Oh, I think it was." And you're like, "Okay, how have you proven that you solved it?" "Well, it seems faster now." And I'll look at it and
Sounds
I'll
like
oh,
I
go
didn't
on.
even do step one.
Yeah. That's true. Yeah. Most people, well, that's what I was saying. Most people don't even do step one. Most people, what they do is assume or they'll be like, I think it's this, and they'll jump right to generating possible solutions. Like they jump basically to the end. And that can work if you get lucky. But usually people don't. And I have literally, like I was talking about, run into people that think they solved it. And I'm like skeptical. So I go and I actually go through this process. And I'm like, oh, yeah, by the way, you didn't solve it. It's still a problem. Yeah. And they'll be like,
You actually made it worse.
yeah, yeah. Oh, I've seen that. I've actually seen that. I've seen people make it worse. And they think they solved it. And all it was is they just got lucky the few last times they were measuring it. And it's, an intermittent problem or whatever. They tested it different. I've totally seen that. Yeah, so that's why measuring is so important. And I don't care how you measure it. I have measured things. I have literally measured things with stopwatches. 15 years ago when we had no like facilities, I literally would get my stopwatch out and do it. And again, in that case, I think I was creating loops to like try to make it easier to measure because it's hard to measure accurately with a stopwatch. But you can do it if you're like, I think the problem is here, I'll put a loop there to make it happen 1,000 times, and if you only see the issue in that spot and not in other spots where you put the loop, well, you know the general area and you can actually measure it. Um,
Well, you're saying that you used to use stopwatches for this example with the scanning. What tools or did you use to measure this effectively?
Yeah, so for this specific case, it was actually one of the easiest because React has, I wouldn't say a perfect, but a pretty good profiler built in, and that's what I used was the React profiler. And so I just turned on the profiler, ran the problem, and when it finally finished loading after seconds or whatever, turned off the profiler, and then the profiler in React, I think if I remember right, it shows like a different frame for every render. So I just like scrolled through till I found the render that took like 1.5 seconds or whatever, and I'm like, okay, boom, this is exactly where the snapshot is for where the problem was. And then once you've done that, once you've identified the like render, or there could be multiple renders that are causing the problem, it depends, but you just have to find one of them. And then the profiler will like show you how long each like component took to do its render. And so you can just easily drill down into exactly which component took longer than it should be taking. And that's so this is a super easy case, but it's only super easy because we've got pretty good tools for it. And like if you're measuring something that's like network related or whatever, it can be way more difficult and you might have to resort to other techniques. But in this case, the profiler was perfect. It got me right to where the issue was.
In the React, the profiler, is that like a browser plugin?
Yeah, so if you install the React developer tools, it comes with the profiler. Um,
Okay. I actually don't have that installed on my, because with the current client we're working on, a lot of the bugs that we were experiencing for a bit were occurring only in Safari, and I'm not sure if
mm,
Safari has React
nope,
developer tools for it.
I don't think so.
So,
Yeah, I
yeah, that's
think
all. I do have it on Chrome though.
Yeah, I think if I remember right, both Chrome and Firefox have it.
hmm I think you can run Chrome extensions within. No, Safari they just switched over to an entire new extension
Uh,
framework.
I
Either way,
It
that's
might
not
be
the
you
point of this
can.
conversation.
Yeah, it might be you can run Firefox ones in it now. I can't remember, but yeah, they're also super limiting. But it actually is a really relevant thing to bring up because that is often where your bottlenecks are. Is things that you can't run the developer tools on. Like if this was a case where so the people using this software are using old iPhones. So if they had told me, oh yeah, it crashes the browser or whatever, and I can't replicate it on like my desktop or something, well, you can't use the profiler anymore. That's just
Right.
so. So it's definitely like in this case, I got lucky and it worked. It doesn't always happen. In fact, a lot of times it doesn't because usually, a desktop with Chrome or something is the least likely place to see bottlenecks. But yeah,
Then you have to go back to the stopwatches and loops. Yeah.
yeah, I mean, so luckily JavaScript has evolved since then, and we can measure. It has like much easier ways to measure things accurately. So you shouldn't have to use a stopwatch literally, but you might have to put one in the code and recompile and redeploy or whatever, which is still a tedious process.
Right.
Um,
So after you've measured everything, what's the next step?
yeah, so I think maybe I'll finish the measuring just in terms
Oh,
of.
sorry.
Well, no,
Of
it's fine.
course.
Just in terms of the anecdote, so we're not lost in the story. But yeah, so what I did is I found that like there were essentially two issues. Well, okay, then the next I'll get into that in the next part. But I found it by drilling in and finding a component that was like taking way too long, and also I noticed that there was a what looked like a bunch of components below that component that was also taking a lot of time. So they all took a small amount of time individually, but like added up, you could tell it was a lot. So to me, it looked like maybe two interrelated issues or whatever. But yeah, I found two areas where things took a long time.
Was it like a was it due to it having to render visually or like process each of these scans, or was it something related to the library, or
Uh,
what kind
yeah,
of
you're good.
like
It's both. Yeah. So we'll jump into the next one, identifying the source. So in this case, it's really easy. We had the profiler, and I could see what it was. Sometimes that takes more work, but it is a step that you should do. And there were two sources. Number one, I'll just first describe how this thing worked. So it was like this carousel, and you could like swipe through each item you were going to scan. And what was happening was if you had 1,000 items you were going to scan, it was rendering 1,000 of these components and actually sending them to the browser. And even though only like 1.25 of them are visible, all the rest were actually loaded into the browser and just, hidden with the display or whatever. So number
mm,
one, that is not great. It may or may not be a problem in some cases. Like maybe you can render that many items and it's fine and you could optimize it and make it work. But in this case, it was definitely like half of the bottleneck. The other half of the bottleneck was the carousel component that the third party library we were using that we are putting these things all in. Definitely couldn't handle this many items very well either. And that was the other, like 50% of the time was just spent in this component when it was being loaded. And you're like, well, there we go. So yeah, you're exactly right. That was the issue. Uh,
well, it's interesting that it's a third party component because we talked about that, I think, in when we were talking about the UI libraries, is like when you just bring in a third party component, you don't necessarily know everything you're signing up for, and these developers hadn't made this, they hadn't accounted for such a heavy load, and now it's like your problem, and then you have to figure out how to build something that works with that third party or
mm-hmm.
modify it, uh, open source if it is, it's
Right.
so it's all interconnected, right?
Yeah, absolutely. And the other thing I should mention too is when this code was originally being written, um, the requirements and expectation was that it would never be more than like 10, maybe 20 items. So, nobody ever thought it was going to be hundreds or 1,000, which we were running into. And so, like, yeah, this is just a case too of like, the requirements change over time, and that can cause issues, that are unforeseen. So yeah, that's. Oh, sorry. You want to say something there, Austin?
No, it's an interesting situation because I feel like that is like a pretty common occurrence, is the requirements do change over time, due to not understanding how things will evolve, with the use of the product. And it's like it brings into mind like premature optimization, thoughts, like how can, like, where is where is the line where you could prematurely optimize this component to be able to scale a lot higher versus like a year later you don't even remember how this component works because you haven't worked with it in a while, and then you're having to go back and optimize it. And it's like where's the trade-off, in terms of like affecting your business, flow,
Yeah.
it's just I don't feel like there's ever a right answer for this one because every time something like this occurs, it's always in retrospect that we go back and have to put out the fires.
Yeah, I actually think there's a pretty good answer, and that is just don't try to optimize for the unknowns in the future. But instead budget. Uh, a certain amount of your time continually to issues like this. Like I call them maintenance issues. So, if I have a team, I would allocate at least 20%, maybe even more, depending on the situation, but at least 20% of the team to always be working on things like this. And this is interesting because I actually, when I started working with this code, I talked to the project manager and basically warned them and said, hey, I'm suspicious of this code. I don't know that it can handle a lot of items. And they were like, oh no, we're being promised it won't need to, but it's definitely like, yeah, it can be hard to judge when to do it. I think for most cases, it's better to sort of delay. Maybe if you're operating at a really large scale and you've got billions of users or something, you need to have your own like internal test suite that like stresses the performance. That would be my recommendation. So like, before you deploy it, you find out there's a performance issue and you can solve it. I think for a lot of companies, though, they can't afford that. And the cheapest way to do it is to delay it. If you try to like do it all up front, I've just found it's not very effective because it's too hard to predict what the actual problem will be. Like, who knows? Maybe we wouldn't have used more than tens of items. Like, nobody really knows. Maybe there have been a different performance bottleneck first. It's hard to say.
Well, it ties into this entire conversation. You can't start with solutions when you haven't even figured out what the
Exactly.
problem would be. Like creating a problem that doesn't even exist isn't smart. So,
Yeah.
all
I
right, nice.
I mean, I actually, so I think this is even more relevant than we're sort of letting on to. I find a lot of programmers, you'll see this with use memo in React. I kind of despise how much people use it because everyone goes, oh, this is gonna be a performance problem. We shouldn't be whatever re-rendering here. And I see it causing so many bugs because people are like, oh, why is this not updating? Or why is it not showing the new value? Or, whatever. And it's because they're memoizing things unnecessarily. So I think like there's definitely a real problem that people do all the time. Or you'll see like if you ever do lower level programming, like C programming, you'll see stuff like that all the time with like loop optimizations and stuff. And you're like, yes, technically, given a specific circumstance, that's faster. But who knows if that's the circumstance we're going to run into? Like it just is not a good use of time. And performance optimizations, if you're like actually optimizing the code, are almost always more bug prone. So you're going to pay a cost there as well. Now, if you're like just refactoring it and rewriting things and that happens to eliminate the bottleneck, that's different. But like if you're going in and like doing use memo or something that it only exists for performance improvements, you are absolutely increasing the amount of bugs in your code base. So you got to be careful when you do that.
I will take note of that. I don't really use Memo. I haven't really seen any places where I've been writing code where I'm like, oh, I should probably use that right now. Maybe once or twice, but yeah, I try not to use a whole lot of stuff ahead of time where I'm not sure if it's necessary.
That's great. I would love if every programmer was like you. Oh.
That's a pretty broad statement. You might want to retract.
I don't know about that. No, I mean, I'm really serious though. I have spent so much of my life working with people that prematurely optimize things. And I mean, I do have a friend who's really, really good at programming and he gets it right a lot of the time. But so I probably shouldn't even say that exception because now every programmer is going to be like, yeah, I'm that programmer. But
Right.
realistically, I don't think I would say less than 1% of programmers are that good. And even then, I don't think it's worth it. But like, just don't do it. Like, it just does not pay off. It adds bugs. and it very rarely actually fixes a real problem. And this is like why we have this process. Like, Owl Creek, this is why we do what we do, and this is why the process is so important. Like, you cannot skip these things or you won't actually do the right thing.
Well, it's actually even better for us if these people don't do it ahead of time, because then it gives us more work later potentially.
Yeah, I mean that's true. I mean it's always like that thing. You could tell people all your secrets, but the reality is most people don't follow them. So yeah, if you don't feel like following this, just give us send us an email. Give us a call. We'll help you out.
So we asked the right questions, we measured it, then what was the third thing that
uh,
we did?
Identifying the source of the bottleneck. What specifically is the problem, or where is it coming from? Then the step after that is diagnosing it, the cause. So what is making this happen? So those are kind of interrelated steps, but I think it's important to have them separate. And that's where we're sort of at now, as we talked about diagnosing the cause. Like the cause was the carousel and adding all those items to the DOM. And now we're on to the part that everyone wants to be on, which is generating possible solutions. So in this case, I looked at a number of solutions. First thing I did was check out the library we're using to see is there any documentation on handling this case? Like maybe it can handle it already for us and we're good to go. Couldn't find anything. Then I checked the bug tickets that they have on their GitHub to see if anybody else had run into this issue and if anybody had solutions. And I found bug reports. Then the developer's response was basically, we're not going to handle this use case. And there were also like some PRs where people like tried to create a solution that would handle it, and none of them got accepted. So it was like, okay, well, the easy route's gone. Yeah. So then I also looked at, maybe using a different carousel library or whatever, but I kind of didn't spend too much time on that because to me, none of those are great solutions. There's no reason to load 10,000 items or whatever into the browser all the time like this. It just, for this use case, we can just show the current item and maybe the item before and after or something like that. There's just no reason to do this this way. So then I looked at using the same carousel library, but sort of having like an infinite scroll type thing where I only show like the current item and the items before and after it. And then when you scroll, changing what those items are, which triggered a whole bunch of bugs in the carousel library. So yeah, so I kind of threw that one out. So then, where I'm at now is basically like talking to the PM and the other people on the team to say, okay, I think it might be the most cost effective if we reevaluate the user experience here. So we have this like sort of scrolling carousel thing. Would it work if we just had buttons on the right and left to go back and forth? Because if we did that, I could make you a solution in half a day that solves all these problems and we're doing great.
Right. And the carousel, it sounds nice and all, but it sounds like it could even be cumbersome to like accurately scanning these things, like you're swiping around and it's like you have to like swipe back and forth to like land on the right one, whereas a button it's just like it's more mechanical perhaps, but yeah, maybe it's even better that way instead of
Yeah.
this nice you.
Yeah, I don't know. Actually, we're still meeting about that and talking about it. We haven't finished that process, and it might be even a completely different solution that we haven't thought of. Um, but yeah, I think the important part, for our conversation here is like, when you're looking at solutions, what I usually do is start with like the obvious things, like is there in this case might say, oh, can I memoize some part of this and make it better, because that would be, if we actually have a real problem and that would solve it potentially. In this case, that is not a relevant solution. So I would look at solutions like that are maybe quick and easy, and they might solve it without having to rewrite a bunch of code or whatever. I couldn't find anything like that here because just fundamentally we can't be loading that many things into the browser without it having problems. I mean, you could if you spent some time on it, but I don't think that's the direction we want to go. We want to keep things to be regular React components and everything. So yeah, I mean, that's what I do first is look at sort of the easy solutions. But then I think it's really important, and something that I think people skip a lot is reevaluating like the user experience or things from a higher level, because what I usually see people do in situations like this is they just try to solve the performance bottleneck technically from a technical standpoint, like using some sort of hack or whatever. Like I've seen people put a lot of effort into like hacking code up to make it work faster, when maybe that's what I'll end up doing, who knows. But I always think it's really important to involve like the business users, the client, whoever it is, and tell them, okay, hey, if you come up with a different solution that looks like this, we might be able to do this way more quickly and effectively and cheaper.
Yeah, it's really smart. And luckily, if the team that I know that you're talking about is pretty good about keeping an open mind with these things, which isn't always the
Yeah.
case. Um, but yeah, it's definitely a smart thing to consider. Not every solution is a software one.
Yeah, absolutely. And in fact, I think I've probably solved more performance problems this way than with actual optimizations, because the reality is optimizations just they can often be time consuming to get right, and to figure out which one to use, and again, a lot of people just go right to that, but I think it's important to not necessarily do that, because when you actually talk to, I mean, if you're doing your own project, you can evaluate it however you want. But if you're like doing this for someone else and you talk to them, usually they're like, oh yeah, I don't want to spend 3 days trying to figure that out or whatever. Like, let's just do it this way. Nobody's going to care.
Right.
Yeah, so we're kind of near the end of this process, generating possible solutions. In this, story, I'm still working on selecting and implementing a solution, which is our last step. And, that's usually pretty straightforward. The important thing, and I didn't put this in my notes here, but after you've selected and implemented a solution, the very important, very critical thing that you must do is measure the bottleneck again after you've implemented a solution. Like, you got to actually make sure you fixed it. And there is actually kind of some ways to make that process go quicker, because you don't want to spend like 3 weeks implementing a solution and then go find out it didn't do anything, it didn't work. So
Right.
I'll actually do, and this is what I did in this case, is I made a proof of concept. It doesn't do like 90% of the features that we would need it to do in the end, but I made it prove that it would solve the actual issue. And I basically always do that, whether it's eliminating some code and seeing if it gets better, or tweaking it, or just do something to prove that you're probably going to do the right thing, before you invest a lot into it.
Well, I mean, like you said, I this whole thing makes me think about the whole process from the beginning. A lot of people think about skipping over asking the question, measuring it, identifying, diagnosing, and they jump right to going into the solutions. When realistically, the first four steps of this flow are actually more cost effective to do in general than just jumping to a solution immediately, because one, you're more informed about what's going on. Two, you can inform everyone that is, quote, up the chain from you of what's going on. It leads to better documentation, better understanding of the code in general versus just piling on stuff. So it's really important to make sure you make time to do the first four steps properly before jumping into just writing solutions. And then, yeah, as you said, going back through them to say like, hey, from a fresh slate, is this actually solved now?
Yeah, yep. That you said it so well again, Austin. Um, yeah.
Yeah, I'm just like a summarizer. That's all. That's all I do.
Well, you do it so well.
Well, I mean, that was the intention too with a lot of these, right? To kind of do a bit of an educational thing and to teach and learn, and so it's great.
Yeah, definitely. Yeah, that's what I really want to do with this is help other people learn and get better at it. And we definitely also love to hear feedback on this. If you have other steps you take or things you do different, I would love to hear about it. I know Austin would. Like
Mhm.
it's a really fascinating subject to me, and I've spent a lot of time on it in a lot of different situations and languages, and I love learning more about it. So yeah, definitely love to hear from anyone. I think that's about tying up our show for the day today. Did you have anything else you wanted to add, Austin?
No, just thank you for taking the time, and also, yeah, don't forget we mentioned earlier on the website owlcreek.studio if you want to learn the fundamentals of like how React is built, and get a little sneak peek for the book that Thomas is finishing up now. Join the email list, and you can check out that publication on LeanPub that we have. Yeah, and thanks for showing up and listening. And we really hope that you reach out and connect with us so that we can have a conversation.
Yeah, definitely. We both love learning about all of this stuff and getting any feedback you might have. And yeah, if you want to learn more about how to, build your own React or how it works, you can follow what Austin said. And yeah, um, I hope you have a good rest of your week or whenever you listen to this. And yeah, see y'all later.